Hey guys, we're going to be looking at right triangle trig ratios and just the basic setup for them. So I'm going to go ahead and start by sketching us out a right triangle, okay, that we will call triangle A, B, and C. Now, one thing that you need to remember is that when we name these angles and sides of a triangle, we use capital letters for angles, we use lowercase letters for side. So you'll notice that in this case, okay? Now, the trig ratios, as we know them, are sine, cosine, and tangent, the main three that we use on right triangles, okay? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, okay? Now, the hardest part with doing this is determining which is the opposite, the hypotenuse, and which is the adjacent. Okay, so let's go ahead and we're gonna work with sine of A. We're gonna look at angle A. So I want to find sine of A, cosine of A, and tangent of A. Now, the first thing we do is we find the angle that we're going to reference. I'm going to say it is right here, which is angle A. When we do that, once we've identified the angle we're starting at, we can identify the sides to that angle. So opposite means clear across on the other side of the triangle. Okay. And then adjacent means right next to. And the reason why I didn't put the C as the adjacent is because the hypotenuse is always straight across from the right angle. So if I was to create a trig ratio of a fraction that said sine of A, I know that sine of A is opposite over hypotenuse. So I look for the opposite, which is A, over the hypotenuse, which is C. So I just write A divided by C. And if I go to cosine, I know that cosine is adjacent over hypotenuse. So in this case, the adjacent from A is B over the hypotenuse, which is C. And then lastly, we have tangent, and tangent is opposite over adjacent. Opposite over adjacent, so we start at A, we go to the opposite, which we've discovered is A, and then it is now over adjacent, which is B. So A over B. Now you may be wondering, well, why on earth is that even important? Because let's switch it and find sine of B. Why is it important that we pay attention to our labelings? So I'm going to do this in a different color. So let's look at sine, cosine, and tangent of angle B. Now, if I shade angle B, okay, if I shade angle B, what you're going to notice and hopefully notice is that the opposite is now over here across from B. So this is the opposite for B. And the adjacent, which is right next to, is where is now A. But the hypotenuse stays exactly the same because the hypotenuse is always straight across from the right angle. So the hypotenuse stays exactly where it's at. So when I write sine of B, I have to go, okay, well, what is the opposite? But now I'm going to use the pink colors. I'm going to say, well, the opposite is across from B, and that is B over the hypotenuse C. And the cosine of B, cosine, is adjacent over hypotenuse. So adjacent is, next to it is now A over C. And the tangent is opposite over adjacent. Now we're using the pink colors. Opposite is now B over A. You can see some formations of what's happening when we use separate angles within right triangles. Those are basic trig ratio setups for right triangle trig.